Hello, this is Dr. Soltis, and I'm going to do a little video here about trying to measure the power that you have remaining in your battery when you have an Arduino circuit. So you might want to be running your Arduino circuit off of a battery, and you might want to report how much voltage is left in your battery. When you drain down the battery, even though it's supposed to be like if you have a 9-volt battery, it's supposed to be a constant 9 volts. As it drains down, the voltage should drop a little bit. And so we're going to look today at how to measure that. All right, so I'm here at my house because of COVID-19, but I have a power supply which is acting as the battery. This just lets me have a little more control over what's going on. I don't have to wait for a battery to drain. And the power supply, I just have the terminals connected here. I have the positive and negative terminals connected to the rails of this breadboard, and then I have a little Arduino right here. To start with, I'm going to build just a quick voltage divider circuit that allows me to basically, if I have an input voltage of, like if I'm using a 9-volt battery, I don't want to put 9 volts into one of my input pins on my Arduino. That would be too much, and so I want to cut it down, and I can cut down the voltage using a voltage divider circuit. In this case, I'm using two 10 kilo ohm resistors that should limit the current that the voltage divider circuit uses, and if the two resistors are equal, then it will just cut the voltage in half that it's going through. So a full 9 volts should read on my Arduino as exactly 4.5 volts when I do that. All right, here's my voltage divider circuit. I have two 10 kilo ohm resistors, one on positive and one on negative, and then they're both connected to the same row here on my breadboard, and that goes over to A0 on my Arduino. So I should be able to do an analog read on A0 and see half of the voltage that I'm getting out of the circuit. And so again, looking at the system, I have it hooked up. I don't have the Arduino plugged in, but I just have basically a short going from power to ground, but it's going through these two resistors. You could see that it's not registering anything on the current draw here. It's still reading 0 amps. That's good. If I just shorted this out, let me do this. It's kind of dangerous, but let me just short it out real quick, and you can see what happens. If I didn't have the resistors there, this might be bad. Okay, it just says it immediately. I turned on the overcurrent protection, so I need to turn this off. I have it set to limit to 500 milliamps is how many amps I have it limited at. So that's just a protection I had in place just so I didn't fry anything. But it immediately went over 500 milliamps, and it would have gotten pretty hot if I had that short. But you can see now I'm not drawing any current at all, and that's good. Okay, so now let's look at what we can read on the Arduino. Real quick, one thing I forgot to do when I was setting up my circuit that's really important is right now I have the battery supply, and then my Arduino is being powered off of my USB port. It's not being powered off my power supply. But you always need to make sure you have a common ground. And so I had to connect my ground pin to the negative side in order to get good values. So let me move over to my screen and I'll show you what we get. The Arduino is 10 bits, and so full power, which is 5 volts, but I'm dividing my voltage by half, so 10 volts would be full power, should read 1023, and then it's gonna scale down from there. So 0 volts should be 0, 6 volts should be about 614, would be 6 would be 1023 divided by 10 times 6, so about that's about what we should expect to see. Let's take a look at and see how we're doing. All right, so we're here in my code. Real quick, just what my code is doing is I set it to check the power every 2 seconds. The one habit I try to get into is never to use delays in my code. Delays can, if you're trying to do a lot of stuff, delays can mess you up, and so I don't want my power checking circuit. I want it to run in the background. I don't want it to delay anything. So if I'm trying to blink LED, when it checks the power, I don't want that messing up with the frequency of my LED blink. And so what I'm doing is I'm calling this function to check power. It says, okay, when's the last time I checked the power? Let's compare it to the current time. Millis is the current time. And is that bigger than my check interval, which in this case I have 2,000 milliseconds for every 2 seconds. I'm checking the power every 2 seconds. You know, probably if you're running a circuit that's running off a battery and it's going to be running for days or weeks, you don't need to check this every 2 seconds. You could check it every couple of hours. You know, so it's just a process that runs every once in a while in the background. But then it is going to, if that triggers, it's just going to read the power level off of A0. And then right now I just have it printing on the serial monitor. So if I open up the serial monitor, it's going to update every 2 seconds. And there we go, 646. I said 614, so we're off by a few percentage, but that's okay. If I go over here, so I'm reading 6.01 volts right now. If I change the voltage, let's drop it down to, dialing it down to 5 volts. So let's see, 5.00 volts. And so you can see this power drop down to 537. And so that's my power consumption. If I bring this up, let's see. If I bring this up, let's try to max it out here. So I'm going to dial it up. I'm at 6. I'm spinning this wheel to up to 7, 8 volts. Went past, hope I didn't break anything. I went past 10. So this is 9 volts at 996, and then I can spin it up. Let's go up to, I'm going to try to stop here at 9 point, all right, I'm at 9.8, and it's reading 1023, which is the most I'm going to see. So I don't want to fry anything, so I'm going to dial it back down. One thing I could do if I want is I could update this. I could normalize it by what I'm expecting. So I could normalize this by, I saw 9.8 was about my maximum, and so I could normalize this and get an actual voltage reading and compare it to the values. Let me show you how to do that real quick. Okay, so I'm going to try to show two things at once here. I have the updated code. So I saw that we maxed out at about 9.5 volts was when I was reading 1023 on my pin. And so I'm just taking my analog read and I'm casting it as a float so that I don't get weird rounding errors. So normally that's an integer, which doesn't have any decimals, but now I'm making it into a float, dividing it by 1023, and then multiplying it by that max voltage, which was 9.5 volts. And so if I open my serial monitor, now I'm at 9.5 volts, and if you look at my serial monitor, it's reading about 9.5. It's floating kind of between 9.5 and 9.49. If I change my voltage over here, so let me change my voltage down to, let's go 7.7, 7.71. Check that out. My voltage is now reading pretty close, 7.7. Going even farther down to, let's go down to 4.6 volts. You can see that this is doing a pretty good job. There's a little bit of error built in there, but that's reading 4.59 volts. So now I have my voltage circuit all hooked up. And if I didn't like the scaling that I was getting, I could change those resistor values, and so that I could use more of the range. But right now I think I'm in a good spot. So all right, so I'm here in Tinkercad recording a video of a simulation of this circuit that we just described. I'm doing this in Tinkercad because there's some technical difficulties with hooking up something to a power source like my computer and reading the serial monitor, and also having it powered from an external display. You could damage your hardware. And so I'm just simulating this same circuit in Tinkercad. We can see our serial monitor down here is reading my 9-volt battery. If I wanted to hook up the battery and have it power the device, I could run, always check your documentation to make sure you know what your input pin is. This VN pin here can handle input voltage. On the Arduino, it's I think 7 to 12 volts, but on different, this is Arduino Uno, on different microcontrollers that might change. Like I know for some of the 3.3 volt systems, they might have like a 3.6 to 5.5 volt range or something like that. So just make sure that you're not putting too much voltage in, or you'll let the magic smoke out of your Arduino and it won't work anymore. So I'm just going to attach that VN pin over here to my battery, and I'm going to make it orange. Just use a different color wire to designate that that's a different voltage. That's a higher voltage than my 5-volt system. So up here on this top rail, I have 9 volts, and then down here on this bottom rail, because I'm connected to the Arduino, that's the 5.5 or the 5 volts. And then always connect all the grounds should be common. So regardless of your operating voltage in DC power, all your ground should be common. And then I have a little virtual multimeter here just to show me what the voltage is reading, just so I can have a sanity check that yes, my power is the same here as it's showing here. So if I start the simulation, I can see, okay, it's reading 9 volts. Start that over. It's reading 9 volts, and my serial monitor would also tell me that I'm getting 9 volts. So that's how it would work. If you hooked this up to a real circuit, which I'll do in my next video, what you'd probably see is the battery would start at a higher voltage, maybe a little over 9 volts for a 9-volt battery, and then it wouldn't change linearly. It's not a linear function. It would drop off. It'd be kind of constant and then drop off pretty quickly down to about 7 volts before you stop getting any useful information at all. So if you were trying to like set an alert like, hey, low battery, you'd probably want that to be somewhere in the upper 8-volt range, because it starts dropping off pretty quick after that. So you could send a notification to the user saying, hey, the battery's low. All right, check out my next video. We'll do some more work with this and see some ways that we can explore this in maybe like an IoT setting.